In here, one speck can turn a perfect wafer into scrap. Wafers move like valuables, sealed, tracked, and handled by machines. Here, the air is a process, measured, filtered, and controlled. Automation keeps humans away from the most fragile surfaces. This is where patterns begin. First, as a perfectly even film. Every rinse is about removing what you can't afford to keep.
Most of what matters here is too thin to see, so it has to be measured.
Once the door seals, the outside world stops existing. This is the make or break moment. Patterns transferred at a scale your eyes can't follow. Finding a defect early is cheaper than building it into every layer. Etch too little, and the layer won't open. Too much, and you destroy what you just built. Sometimes the cleanest tools don't touch at all. They vibrate the contamination loose. Everything is designed so humans never become the contamination source. This step changes the silicon itself, tuning how it conducts electricity. When layers don't line up, the circuit doesn't exist. Precision is the product.
Every check is a gate, because fixing a mistake later might be impossible.
Even the pattern template travels sealed, because dust doesn't just ruin wafers. This is the step that turns chemistry into geometry, layer by layer. Lithography draws it. Etch makes it permanent. Most defects aren't dramatic. until they become a dead chip. This is why chips take so long. Precision is repetition. Planarity isn't cosmetic. It's what makes the next layers possible. Every dot on that map is yield, earned, or lost. Some of the most advanced wiring happens in a controlled bath. You don't just build layers, you stack accuracy. This loop is the factory's engine. Repeat it enough times, and you get a chip. In a fab, the cleanroom is the first tool. It looks calm, but this is controlled violence at the atomic scale. You don't assume it worked, you prove it. AI chips aren't made in one breakthrough. They're made in relentless control. Before you can connect layers, you have to open pathways between them. This is where empty space becomes a conductor. To build upward, you keep coming back to flat.
This is the wiring layer, where the chip starts to look like a system.
At this point, the chip is mostly alignment and discipline. A tiny cluster of defects can decide an entire wafer's fate. This is how complexity accumulates, one controlled loop at a time. Even a perfect tool can't save you from a careless moment. After all the layers, the next question is simple. Does it work? This is the moment the wafer stops being a project and becomes a measurement.
In a fab, failure doesn't look dramatic. It looks like rerouting.
After all that automation, the product is still measured in millimeters.
Reliability is often a liquid you'll never see once the chip ships.
At the end, the question isn't how it was made. It's whether it performs. Traceability means every failure can teach, and every success can be trusted. Even now, one cluster can decide the fate of thousands of chips. Particles leave patterns, and engineers learn to read them. Passing isn't an emotion here, it's a route. This is where the factory stops guessing and starts proving. In this world, maintenance is manufacturing.
All that infrastructure so something this small can be trusted.
After hundreds of steps, you earn a single color, green.